Hey kids, Smath here. Got the final video installment for new material for the year. This is our last video, kids. Here's what I've got for you today, a little electrolysis. Now, what we've been doing up to this point in electrochemistry is basically running a galvanic cell forward. When we run a galvanic cell forward, things are going to basically get oxidized for the most part. There is some reduction on one side, but for the most part, we're looking at that oxidation to run the reaction and drive those electrons across the bridge, across the voltage. Well, now in electrolysis, we're going to run things backwards. Remember, we had this equation where delta G is equal to NFE. The only reason I bring that up is because we need this F. This F is called Faraday's constant. Faraday's constant is basically how many coulombs, that's charge, how much charge there is per mole of electrons. So basically what we're saying is if you had 6.02 10 to the 23rd electrons over here, that you would be generating about 96,500 coulombs. So coulombs are really very, very small, but it's an amount of charge. Now, the other player we need to introduce here is an amp. Amps are basically how much charge, coulombs, per unit of time. You're going to learn more about this in physics when you do circuits, but for our purposes, it's just how much charge per time. So when we're looking at these problems, the takeaway we're going to have is we want to get to moles of electrons, because from moles of electrons, we can find out how much stuff, how many grams of material we're going to need. So we get a mole of electrons by using Faraday's constant here times the amperage times the time. So basically what we're looking at is time, amps, and Faraday's constant. That's the breakdown of what we're looking for. So let's look at our sample problem. We want to know how many grams of copper can be reduced. So we're going from copper 2+, reducing it down to copper solid, can be reduced by applying 3 amps of current. That's not very much, just to be honest with you. 3 amps of current for 16 minutes, 16.2 minutes, to a solution of copper 2+ ions. Okay, they're telling us it's copper 2+, so now we know our mole of electrons, and that's going to help us get out of this problem. So the first thing I'm going to do is I want to start with time. So we have 16.2 minutes, and that does me no use whatsoever in the minutes form. So I'm going to take that minutes, and in 1 minute, there is 60 seconds. And now I can use my amperage. 3 amps is the same as saying 3 coulombs per second. So now my seconds are going to cancel. And now I'm going to use Faraday's constant of 96,486 coulombs per mole of electrons. And here's where it's going to get a little bit tricky, is that in 1 mole of copper, there are 2 moles of electrons. And now to get to the grams, 1 mole of copper, 63.5 grams. That's one of those ones that we keep out to the half. And so if we munch them, crunch them, let Texas Instruments do most of, if not all, the heavy lifting here, we're going to find out that it's going to plate out 0.96 grams of copper is going to come out of this solution. So basically all we did was we took the time, turned it into seconds, multiplied it times the amperage, divided by Faraday's constant, found out how many moles they were transferring. We found that out because they told us it was copper 2+. Copper 2+ had to go all the way down to copper solid to come out of solution. And then we just grabbed the molar mass off the periodic table. This is a way of plating metal onto another metal and finding out how much we want to plate on or add on to our metal. This is done commonly with cheap jewelry where they may take a piece of copper and they'll just plate a little bit of gold. This is a great way of not having to make the whole piece of jewelry out of gold, but make it out of something less valuable like copper, and then just put a gold layer on the outside. And they do that by just running a current through, an amperage through it for a set amount of time to plate out a certain amount. I'm Smath, this is Electrolysis, and I hope this video helped you.